All right. So I see a lot of people are joining. So good morning, everyone. We're here for our first webinar on ISO 8800. I hope you're all settled, have a coffee and a water. So this is the first webinar between our two units, Functional Safety and AI Department. We're super excited to be here this morning, learning something about the new standard for AI safety in the automotive industry. So with me here today, we have our two experts, one from the functional safety team, which is Narcis,
Hello.
and from the AI team, we have Sergio here in the room.
Hello, everyone.
Hey, everyone. So I see still people joining, so we still keep a little bit to the introduction. So today we'll talk about what is happening actually between the two technologies, how the new ISO is impacting, what challenges arise, and of course, how is DECRA actually able to help customers to overcome that. So I see, no, a lot of people are still joining, so that's great. So numbers go up. So Narcis, maybe you get already prepared to take over and jump in so that we can start.
Yes. Well, as Janina was introducing, this is Narcis. I will talk about functional safety, okay? And Sergio will go after me for my brief introduction of safety, okay? The agenda of today, as I was starting to say, firstly, it's the introduction, and after that, Sergio will go deeper on the ISO 8800, and we will go finally with the final remarks. Okay. So let's jump. Okay. Introduction of FUSA. Well, this is Narcis. I've been working with functional safety for several years. If you want to check a little bit on details about who I am and what my experience, just check on LinkedIn. Okay. So firstly, I would like to start with a brief introduction about what is functional safety. Okay. The main description of functional safety is that it's an engineering field that prevents from failures that lead to a malfunction that implies an injury or fatality. Okay. As a formal definition, we have a differentiation that is pretty important between safety and functional safety. Safety itself is just the absence of unreasonable risk, okay? But functional safety could be also, is when you apply this unreasonable risk to the hazards and caused malfunctions behavior, okay, of electronic and electric systems. And here, what advantage we have from applying functional safety in the different engineering fields? Okay, firstly is quality. Safety is binded to the quality because when you want to avoid failure rates, you also means that your system has to imply a quality. So these both standards are binding and include these norms on your products and your systems and designs, improve the quality of the electronics and electrical systems. Also, what more? Obviously, to prevent this hazard and potential life-threatening, it means that if something failure and fatal can occur on your electronic system, it is prevented by safety. This is the norm on the design. And also the customer trust. Nowadays, we are having a very long change of suppliers, and if you want to control the quality and the designs from your suppliers, apply safety norms implies that you improve your quality of your systems. And finally, also legal protection. If you can prove that your system is safety and works as is expected, at the end, if there is something happening, safety will cover it. So, okay. With that general view, we'll move to the functional safety standards. We have the main one that the more general and global is the IX 61508. This can be applied in all different types of safety electronic systems, okay? And in that case, we will focus more on functional safety. Functional safety is daughter or son from IX 61508, but ISO 2622, it goes deeper. And as it goes deeper, it starts to have more collision with these new fields that we are finding, okay? as what I was introducing, okay, the relation between the IEC and the ISO 262, that is a data that has deeper knowledge on it, it starts to find different fields that cross over the ISO 262. In that case, with that scenario was created the SOTIF, that is the intended functionality. Because safety is functionality, but the intended functionality it could be really problematic. So at the beginning, the 21448 was created for the ADAS systems, one of the ECUs in the car. But as it gets more bigger on these different new software fields, it was not enough. So at the end, we had to create the ISO 88000 that today will introduce Sergio Dippler. And this ISO 8800 has a lot of correlations and relations on the ISO 26262 and the SOTIF that we set. Okay. So finally, what happened when our ISO 262, that is the deeper and the ones that we have on Automotive, find an AI component. So here we have a problem that generally the safety functionalities have a sensing, a processing, and reaction. But during this process, if we have a artificial intelligence algorithm, we have a problem that is not deterministic. When we are calculating the safety goals, we always need to know exactly what will be our output. We will need, and here the AI algorithm, it changes depending on a lot of things that are pretty complex. So we are talking about a not traditional software that is a different type of software, difficult to determine the output, and for that we will need to take this element and consider it in a different way. And these different ways, the ones that Sergio will start to explain and introduce how it's treated in the 808000.
Okay, perfect. Thank you, Narcis, for taking us through the fundamental parts of functional safety and evolution. One thing, because we have already a couple of questions in the chat, so we will share the slides later on. We will also share the recording, so no need to screenshot or anything. So don't worry, this will be sent out automatically later on. So, and if there are any questions, please feel free to put them in the chat. We will first now focus that Sergio explains the details, and then we have a question part at the end, okay? Thank you so much. And now the stage is yours, Sergio.
Okay, thanks much, Janina, and thanks, Narcis, for your introduction of the functional safety topic. So now on my side, I would like to start from the part of Narcis was mentioning about the challenge that we have today, that it's why the standard functional safety methodology cannot be applied to AI. As Narcis was explaining perfectly, the AI elements have to be considered in a different way than the traditional software. And with this slide, what I want to highlight is the main difference, that for AI is the using of data, the part of the model that it's needed to be trained using data. So what AI is doing is identifying these patterns based on that data. And this is also possible that the AI starts learning or changes the learning along all the life cycle. It means that when you start changing the data, or at some point, if you want to change the data, it means that you can retrain the model and the model will behave in a different manner. And here in the slide on the right side, we see a simplified flowchart diagram in which we see how we are inputting the data to the AI model, and then the AI model is inferring and giving us some outputs. But in one separate step, we have that we need to train the model, as I have mentioned before, with some raw data that we need to create a training data set, and then training and verifying the model with a testing and validation data sets. On the other hand, we have the traditional software that, as you all know, receives some specific commands based mainly in some rules, and then performs the programmed task. This is specifically programmed for executing one task. And as Narcis already said, this software behaves in a deterministic way. It means that The output is always the same based on the same inputs. Now, and before talking about the ISO 8800 deeper, I would like to talk about the regulation, the European regulation in this case, and how it affects to the automotive sector. So you see here in this slide this pyramid that defines the risk approach that the European regulation is giving to us. So the European Commission proposed the Artificial Intelligence Act in April 2021. This act aims to regulate the use of artificial intelligence within the European Union, focusing on, as I mentioned, this risk-based approach. The AI Act defines, as you see here in the pyramid, 4 different levels of risk. If we go from top to bottom, first we see the unacceptable risk. These AI systems considered to pose an unacceptable risk or to individual safety, rights, or the freedom of the people. In that sense, the AI Act is saying that these systems will be completely prohibited. And as an example, we can mention different examples like social scoring in public spaces, manipulating people behavior, etc. If we continue going down in this pyramid, we find the high-risk AI systems that are the ones considered to high risk due to their potential to significantly impact the fundamental rights of the people or the safety. In this case, what the AI Act is saying is that they will need to undergo a conformity assessment, even if it's internal one at some points or external conformity assessment. In this field, we find some examples as critical infrastructure, transportation, education, employment, and along, etc. Then, if we continue in the pyramid, we find the limited risk AI systems. For these ones are the ones that obviously set limited risk to the fundamental rights or the safety of the people. In this case, we find chatbots and non-critical systems, and what the AI Act is saying here, and that this kind of systems has some transparency obligation. And finally, on the bottom of the pyramid, we find the minimal risk AI systems that are the ones that obviously are not attempting to the safety or the human rights at any case. And the regulation is giving us no restrictions here for these last ones. But today, what I want to highlight is the high risk category, because this category, so the applications that are falling into this group, the high risk AI systems, have an extra batch of requirements, harder obviously than the other ones, that need to comply. In this case, I'm talking about risk management system in place with a quality management system in place also, governance and the quality of the data sets, a clear strategy for record keeping through logging mainly, obviously transparency and information to the users. And then, as I mentioned, the conformity assessment part, even if it's internal or by a third party. And finally, I think it's important to mention here that we have 3 more technical, if I can say it, requirements that are the 6, 7, and 8, accuracy, robustness, and cybersecurity. But the question here is, how is it, or how is this applying to automotive? Well, first of all, on the left part of that box, that pop-up, we need to identify, or we need to know how to identify a high-risk AI system. So what the regulation is saying in this field is that if the AI system is a safety component of a product, or the AI system itself is a product covered by the Annex 1, so in the Annex 1, we have a list of union harmonization legislation. In that sense, if the AI system is one of these cases and then requires to undergo to a third-party assessment, it means that it's falling under the category of high-risk AI system. Let's go to the right side and let's see directly an ADAS component that can be, for example, if we can focus on ADAS, let's say automated braking system, emergency system. In that sense, obviously, it's a safety component, and this is covered by Annex 1 as the type approval appears on the Annex 1. It's true that appears on the Annex 1 Part B, but still on the Annex 1. So first tick done appears on the annex one. So we have the first tick, and then obviously the vehicle is required to undergo a third-party assessment. So we have the second check. So this ADAS example, automatic emergency system, is falling into high-risk AI system category. And then before starting with the 8800, I would like to give a glance of the, let's say, the key events or the key deadlines that we have for the complement of the EU AI Act. So as probably some of you know, AI Act entered in force in August 1st, 2024. And we have, after 6 months, it means February 2025, that the prohibited systems will be completely banned. After this, after 12 months, we have, let's say, August 2025, we have that the notifying authorities must be defined. This means that each EU member state is responsible for establishing its notifying authority. So it's dependent on the country and could be even a new body or an extension of an existing already functioning bodies under this product legislation that can be, for example, machinery devices or medical device regulation, just as some examples. And also, after these 12 months, the GPAI rules apply. I have not mentioned before, but we have in the regulation, we have specific rules for the general purpose AI systems. Some examples, ChatGPT and Gemini and etc. Then, after 24 months, it means August 2026, we find that the rules for list of high-risk AI systems apply. So the requirements that I have mentioned in the slide before. And after 36 months, probably the hardest deadline, let's say, it's August 2027, we have that the rules for interplay with other product safety regulations apply. So, as I explained before, there were examples for ADAS, for example, and a lot of other ones, for example, medical devices utilizing AI or machinery plus AI. Now, let's jump directly to introducing ISO 8800. And first of all is to identify the purpose, the scope, and key concepts and risks. But first, starting with the purpose. So the purpose of the ISO 8800 is to provide industry-specific guidance on the use of AI in safety-related functions. And here, super relevant to say safety-related functions. Then the scope, it applies to the safety-related systems that include one or more electrical and or electronic E&E systems that use this AI technology installed in series production road vehicles, excluding the mopeds. And here, super interesting also to say, series production road vehicles. If we move to the right side and talking a little bit about the key concepts, ISO 8800, in addition to providing guidance for tailoring, because Narcís also explained this or mentioned these two ISOs, extending or tailoring the ISO 26262 and the ISO 21448, this document focuses on the principles that support the creation of an assurance argument for the safety of the AI elements within onboard vehicle systems. So here, support on the creation of the assurance argument, an assurance argument for the safety of the AI elements. This document, the ISO 8800, also describes some safety-related properties of the AI systems that can be used to construct this convincing safety assurance argument. And then finally, ISO 8800 focuses on the subclass of AI machine learning. So it's not focused on a specific methods, AI methods that can be neural networks, for example. It's just for the global machine learning category, let's say. If we move to the bottom, to the part of the risks, functional safety related risks associated with a malfunctioning behavior of an AI system are addressed by tailoring or extending the relevant clauses from the 26262 series, part 4, 6, and 8. These risks related to functional insufficiencies in the AI system are addressed, on the other hand, by extending or tailoring the ISO 21448. And the last point, and super relevant, that the hazard analysis and the risk analysis are beyond of the scope of this document. These analyses are considered a part of the vehicle level system safety engineering activities. So both include in ISO 26262 and the ISO 21448. So now probably the question is, okay, but where we are applying ISO 8800, tailoring and extending the 26262. So here in this graphic, we see both ISOs. We see that we are identifying an item on the top, and then we identify two systems. First one, a system that it's non-containing any or no AI systems and its elements. So in that case, perfect, as it is not containing any AI system, we use, as we were doing, ISO 26262. But then what is happening when we find an AI system? We have two options. First one, on the left side, that the AI component that we have, the software component, does not contain any AI model inside, or it's not the AI model. In that sense, if it not contains AI model, we use ISO 26262. Then on the right side, if the inside the AI system, we identify an AI component that it's the AI model itself or contains an AI model, then yes, ISO 26262 series can be tailored and applied in combination with the ISO 8800. So let's go a little bit deep dive in the ISO 8800. First of all, I think that it's relevant to introduce you what the ISO 5338 is saying to us, that is the ISO about AI system lifecycle processes, and this ISO is introducing us this AI system lifecycle. In this lifecycle, we see the typical phases that an AI system is going through from the left to the right. First, we would start with inception, where the business or the vision analysis is done, stakeholder needs and requirements definition, system requirements definition, etc. Then we move to the technical part, design and development. In this phase, there are happening a lot of things inside: design definition, architecture definition, system analysis, AI data engineering, implementation, integration, etc. Once we have done it, let's move to verification and validation activities. And once we have verified and validated our AI system, let's move to deployment, that it's obviously transition to life of our system. Once we have the system deployed, we jump directly to operation and monitoring, where we also can include inside this block or inside this phase the maintenance. And then we have two options. If we need to, because we have some changes in the input space, for example, and we need to retrain the model, we go to a phase of reevaluation where probably we will need to collect more data, or we need to readapt or change the data and then retrain the model. So we can have this block of reevaluation. And then obviously we have the continuous validation phase. And finally, we move to the system to the requirement. Why I'm explaining this is because the ISO 8800 proposes also an AI lifecycle, but ISO 8800 is naming it AI safety lifecycle. And this safety lifecycle covers the activities from the system development to the deployment and the operation. If we look in this diagram, and we start from the left top side, we have the encompassing system development, where, as I explained in the risk part some slides ago, the hazard and the risk analysis is beyond of the scope of this document, so it's done at the encompassing system level. But once we have done this, we need to allocate certain number of requirements to the AI system, and then we need a phase of refinement of these requirements. Once we have done this refinement, that obviously you need to know, or you need to have knowledge about both worlds, functional safety plus AI, then we move to the V model, that is the AI design, verification and validation, typical V model that I will go a little bit deeper later. And once we are inside this block, we have two options. First one, if we move to the bottom, it means that the requirements or we are not being able to achieve the requirements or to comply with the requirements that we stated and refined it before. So we need to go back and refine again the AI system requirements. But if yes, if we are able to demonstrate that we're achieving these requirements, we move to the next block, that is the evaluation of confidence in the assurance argument. In that block, we have again two options. If we are or we cannot be enough confidence in the assurance argument, we can go back and re-enter again in the V model. And if not, we can even go back and another step back and go to the refinement of the requirements, the AI safety requirements again. But if yes, if we are sufficient confidence in the assurance argument, we can move to the last phase, that it's the operational and the continual assurance. Obviously, in that part, as I have mentioned before in the other AI lifecycle, if we have some insufficiencies that we detect during operation or some changes in the input domain, imagine that, for example, we had not considered a type of signal, then we need to introduce more data to our AI system and retrain, then we can or go back to the assurance argument or even go back to the beginning to the refinement of the safety requirements. And then this is how both ISOs or both life cycles are merging. So obviously, this V model stays on the design and development and verification and validation, as it's super clear. But then we have the operational and continuous assurance block containing the other like 4 phases, we can say it, from the AI lifecycle proposed for the 5338 ISO standard. It means that in this AI safety lifecycle proposed by the ISO 8800, we have 2 blocks, 2 really relevant blocks that are super related with the functional safety. That are the first one, refinement of the AI safety requirements, and the confidence on the assurance argument. These blocks are not considered before in the other in the other AI lifecycle because they are super functional safety related. Because of that, ISO 8800 is introducing to us. Then, if we look a little bit deeper on the V model, this AI system design and development phase or these activities are iteratively performed until we have sufficient level of performance with respect to the safety requirements, and we are able to demonstrate it that we are achieving the requirements. And then when we have the associated work products generated. So ISO 8800 is written in the same way as 26262. So we have per each of these blocks some work products associated. In this sense, we have 4 phases, 4 generalized phases. Also, it can be decomposed in other ones, but just for simplicity, we have here identified 4 phases. First of all, selection of AI and AI system design. In here, we have AI component implementation and AI system implementation also. Then we have data specification and collection for training and testing. Then we have the AI system verification and validation, and then we have the AI safety analysis. Important to mention here is that the AI safety analysis and the data specifications are tasks that will be performed along all the V model. But just for, let's say, showing it here today, we have, for simplicity, we have added it in blocks, but it's true that both tasks should be performed along all the V model. Then if we start commenting some of these tasks, we can start talking about probably the most important thing about data, or the most different thing in between the functional safety ones. So ISO 5338, the one from the AI lifecycle, also presents a data lifecycle that I have not included here because a lot of diagrams and it has no sense to also explain another one. But if we look at ISO 8800, this ISO states another data lifecycle, but from the functional safety perspective. This new lifecycle is essential to, let's say, execute all these or to include all these activities that are here in the bullet points. So sorry. So from gathering to creation, obviously the safety analysis, verification and validation, management, and maintenance. Important also to mention here that this dataset lifecycle can be applied to each of the datasets that we split from the development side. So in the typical AI development, we have to split our full dataset in a training, validation, and test dataset. In this sense, ISO 8800 is giving the flexibility to, as developer decision, if apply each lifecycle model to each dataset or only apply one dataset lifecycle model for the full dataset. Now, if we look deeper this dataset lifecycle model, inside this model, we find just in the middle the data safety analysis. That is the first step of the lifecycle and focuses on identifying the safety relevant dataset insufficiencies. Super important. Dataset relevant insufficiencies. After that, and we see here with some dash arrows, this information is fed as inputs to the dataset requirements development, the dataset design, and the dataset implementation. Depending on which dataset lifecycle phase we are feeding, different approaches to execute this data safety analysis can be used. And as an example, we can say HACCPs or, for example, process failure mode and effects analysis. Okay? It's also relevant to mention for this slide that the ISO 8800 is also mentioning other ISOs from the AI world. In this sense, it's talking or citating the ISO 5259 series. And why? It's because the ISO 8800 is introducing some concept that it's called dataset related safety properties, from which the ISO 8800 is saying that it's possible to extract also some dataset insufficiencies. So what kind of, or which are some examples of these dataset related safety properties? Well, from the data, they are extracted directly from the ISO 5259 part 2. And we have some of them like timeless, currentness, accuracy, etc. A lot of some other qualities, okay? Now, if we jump to AI system verification and validation. Probably the more relevant question that we can ask ourselves is, how do we can test our AI system? So, well, testing an AI system shall be performed on the AI component that can be tested standalone. ISO 8800 is saying that we can test our AI component with the AI model standalone. But obviously, we can test it on the integrated AI system. Moreover, the ISO is proposing us 2 extra levels where we can, where testing can be performed, having a total of 4 levels. In this sense, we have another testing level that is the integration of the AI system with the encompassing system, and then we have a final testing possibility that it's to test after or post-deployment validation. Then, if we look deeper, the first one, the AI component testing, ISO 8800, as I mentioned in the key topics just in one of the first slides, the ISO 8800 is proposing us what it's called safety-related properties of an AI system. They are nothing else than typical characteristics of the AI that probably, if some of you are AI developers, most of you know, we have here robustness, also hot topics that we are hearing in the press and in other things: robustness, bias and fairness, explainability, controllability, etc. So the ISO 8800 is giving us these safety-related properties to start or to use as a starting point for execute different kind of tests. Okay. And finally, let's jump to the evaluation in the evaluation of the confidence in the assurance argument. So ISO 8800 requests an assurance argument, as I explained in the first slide, for the fulfillment of the safety requirements allocated to the AI system. This assurance relates to the claim that the AI system obviously is achieving safety. An assurance argument, what it's doing is communicate the relationship between the evidences and the AI safety requirements. ISO 8800 is proposing us some model-based graphical representations, as you see here with these two diagrams, that can aid the communication and the evaluation of these assurance arguments. Here, the example that I am showing to you today, it's based on the global structural notation, the GSN, but it's also possible to use another graphical notations like the claims assurance argument, evidence, or the structured assurance case meta model. If we start looking deeper in this notation, we see that we are starting, or we are using as a starting point the goal, as ISO 8800 is saying to us, that the safety requirements allocated to the AI system are fulfilled. From this, we have on the left side some context and then some assumptions to support this goal, but then we define a strategy to achieve this goal. Here, the strategy in soft green is saying that the functional insufficiencies that could violate this goal that we are presenting in the beginning have been prevented, minimized, or mitigated. And from this, we start launching or identifying extra goals to subdivide our problem. In this case, and just for simplicity, I have only developed one of them, that is the potential insufficiencies of the AI system have been addressed. These potential insufficiencies, then you need also to trace or to further develop another strategy that is that these insufficiencies in the identification have been identified, minimized, or mitigated. In that sense, from here, we can start going farther and farther and farther, but just for simplicity, I have selected 2 or 3 solutions that we can apply, for example, to the goal that is to define the input space sufficiently well defined and completeness. That it's not an easy task at all, because if some of you are already developing ADAS solutions based on AI, having this input space well defined with all the data needed, with all the use cases, is not an easy at all. So here are some solutions that we can give to solve or to achieve this goal is that, well, a super good and bounded definition of the input space, knowing pretty good which are the triggering conditions for our AI system, and along etc. here. This diagram, this example that the ISO is proposing is just a general example for starting, for example, a supervised learning AI system that can be, for example, pedestrian detection, typical use case. But for sure, this will need further development to have a real confidence in this assurance argument. And until here, this is the presentation that we have for you today. But I would like to finish with some key takeaways that we have collected from this webinar. First one is that the ISO PAS 8800 complements ISO 26262 and ISO 21448 when we find an AI component in an AI system. So when we identify that an AI component, as I said before, is containing the AI model. It's not enough, also Narcís mentioned this, it's not enough to use the typical functional safety strategies, then ISO 8800 is helping, extending and tailoring this both. If we move to the next one, ISO 8800 work products are compatible with high-risk AI system EU AI Act requirements. What does it mean? It means that if you remember the slide of the EU AI Act, some of the high-risk AI system requirements, one of them is robustness, for example. And then the ISO 8800 is also presenting to us some of the safety-related properties, and one of these properties is the AI robustness that you need to test at the AI component level. It means that when you are testing your AI component from the perspective of the functional safety, you can also start testing from the regulatory perspective. If we move to the next one, implementation requires functional safety and AI subject matter expertise. And this is probably the most important key takeaway from here. We need both profiles to start applying this ISO standard to the AI systems. And first of all, and probably the most important, where both worlds are mixing is in the derivation of the functional safety requirements and allocating them to the AI system. There, for sure, we will need both profiles. Then, safety and security of vehicles needs to be ensured from a holistic perspective. I will not detail more on that, it's super clear. And finally, we as DECRA can support you with ISO 880 compliance and for sure in other safety related topics as we have been doing from more than 95 years. I would like to close this webinar before the questions, just saying that or showing you the scope of the services that we have. Our solutions are tailored to meet the specialized demands on the OEMs, Tier 1 and Tier 2 suppliers, and we offer customized and global support throughout the product lifecycle. Here you see the services for functional safety, including SOTIF and ASPICE, cybersecurity department and AI department. Because we in DECRA, the strategy that we have is that we have started working together, these three departments, functional safety, AI, and cybersecurity, because not only ISO 8800, also another standards, will need to combine this knowledge from different profiles. And we, as DECRA, really think that it's super relevant to start working together. And yeah, I leave here both contacts from Narcís and mine. More than happy to receive some emails from your side asking questions or to collaborate with you and to help you in this ISO 8800 and the difficulties that it has. And yeah, until here, I think that we can jump to the questions and answers. Thank much all for your attention.
So thank you, Sergio. Thank you, Narcis. So we have a couple of questions in the chat. So, but I have to correct you first. So it's not 95 years. Next year, we have our 100-year anniversary as DECRA. So this is an important fact. But you just showed actually a slide where you showed the different departments and how they work together. And I have a question related to that. So we have a question here that actually asks if wait, no, I jumped my screen. If AI software is actually connected to ASPICE 4.0, and if you can share any, best practices related to the AI model for that.
I can take that one. So we are also considering, and we are working together with the functional safety department on regards of ASPICE version 4.0, because it includes some parts, one extra block on the bottom for ML activities and one extra block for data. So yes, the point is that yes, we are working together to also offer this kind of services combined.
Okay, excellent. So, and then we have here a generic question. If you could, talk a little bit about best practices for the ISO 8800.
Best practices.
Mm-hmm.
Okay, in that sense, first of all, it's super relevant to have clearly stated the requirements. And this is probably the best practice that I can give to you. Having the best practice, having the requirements really good allocated, that the ones to apply to the AI system. And then finally, having all the technical documentation as much as possible well documented. This is probably one of the best practices that I can say to you.
Yeah, and I think for further discussions, please reach out. Feel free. Sergio just shared the contact details. You will get all the presentation later on. We have also a very interesting question. Gareth asks us, how does ISO 8800 relate to ISO 4569?
Okay. I can take that one also. ISO 4569 is the basic ISO for combining functional safety plus AI. Is the first ISO that appeared for start treating the things of functional safety on AI systems. But well, let's say that it is more a general perspective of how to treat functional safety for AI. And the ISO 8800 is really focusing on road vehicles. It's true that also this ISO can be applied at some point, but obviously it's better to, let's say, specify that for road vehicles, it's quite better and quite let's say, good to start establishing ISO 8800 instead of the 5469. But it's worthy also to mention that for other verticals, as can be, for example, machinery, we can start applying 5469 ISO standard for functional safety plus AI.
Okay, so thanks. And we have also a very good question. So does the ISO that we talk about here introduce new safety engineering methods, or can we still use the methods defined in ISO 26262?
For the methodologies and all of these things, functional safety experts are leading here. So ISO 8800 is just mentioning the other 26262 and 21448, and that's it. It's not going deeper into any of the methodologies, let's say.
All right, that's a good one. So let me check. We have also a question. When is ISO 8800 expected to be integrated into stakeholders' designs to ensure it is ready for market launch?
Well, super good question. Difficult to say that. Actually, ISO 8800 is not published yet. It's expected to be published by the end of year, beginning next year. Then, when it's ready to start be applied, it's a difficult point to say. Probably the market will say yes when this can be start to be applied. I would expect to have it starting by the OEMs and tier ones and tier twos by middle next year, something like that. It's true that first it's needed a phase to understand how we are applying this. It's not easy ISO. There are a lot of concepts to understand, mixing both worlds. It's true that I think nowadays we do not have at any company profiles mixing functional safety plus AI, because this is a profile that was not existing in the past. So now we need to create these profiles, and because of that, Indecra has the decision, the strong decision to work together with the departments, because we need to create this knowledge. We need to create this knowledge together with functional safety experts, AI experts, and also cybersecurity experts. Because of that, we are doing this in Indecra.
Yeah. Okay, so then we have a question, or actually two questions from Buzgudan. He would like to know what is actually, if you can deep dive into what is actually a dataset safety analysis and what is an AI safety analysis?
Well, there are really pretty different, just to mention, but probably this is much deeper content that we can express you in afterwards or in another session, in another training more deeper, because it's not easy. ISO 8800 has specific chapters for both, and it's giving us some examples and how to apply this, but it's quite much more deep dive into that. So this is just for other sessions or another trainings.
Okay. So let me quickly check our chat. And there is also another question asking if should safety extend its scope on the trained data set?
Yes, for sure. In both datasets, we have to extend it. As I mentioned, we can apply the dataset lifecycle just for all datasets, train, test, and validation, or just for the training dataset, and then another one for each dataset. But obviously, yes, we need to apply it for training datasets.
All right. Now we come to a more complex question.
Wow. Okay.
How the tool chain used in AI systems and software development will be considered under the requirements from ISO 26262 and the confidence in the use of software tools.
Narcís, do you want to add something here?
Well, this is the part of the ISO 262 that applies that the tool that are using against safety. He's wondering about if the tools that you are using in AI, also how they apply it, using the same process that is on safety, or there is additional thing for the tool chain that is used on AI.
I can add some point. Apart from applying what Narcís mentioned, ISO 8800 is showing us a specific chapter on the confidence of the AI tools and the machine learning framework development. So it gives us some premises and some statements to understand and how to analyze these tools and also the software development frameworks. Yes, it's possible, but I think it's also for a more advanced training.
Okay, so then let's pick up Christoph's question. He asked, how is the assurance argument compared to the acceptance criteria to prove safety? Wait.
Proof safety is achieved.
To prove safety is achieved. Yeah, that is it. Yeah. Is there a need to quantification?
ISO 8800 is saying nothing about that point. I think assurance arguments. So ISO 8800 is showing us how to, or let's say the details or the guidance in how to complete this assurance argument. But for the rest, I think we need to relate to the functional safety ISO standards like SOTIF and 26262.
All right. So then let me pick up the three more questions. So what is the relation with the upcoming standard ISO 5083?
5083. ISO 8800 is also mentioning this one and the last one, that it's the 40 whatever. I don't remember exactly the name. But the ISO 5083 is introducing an example of what ISO 8800 is saying. So in how to apply most of the concepts, of some of the concepts, to a real use case that can be, I don't know, emergency braking system or another example that you can think of. And this new ISO is taking into consideration all the statements from ISO 8800. So this ISO will give us a very good example to start applying ISO 8800.
Okay, so I hope that answered the question. And then Akshay has a question, how does ISO 21434 relates to ISO 8800?
434, Narcissus is the one for cybersecurity, right?
Yeah, it's the automotive and cybersecurity.
The automotive one, yeah.
Okay, from this point, ISO 8800 clearly states in some point that cybersecurity topics are not considered inside the ISO 8800, but I have to mention that it does not mean that we do not need to consider them. Because of that, we are merged these three teams inside DECRA, because we need to consider also some risks on regards of cybersecurity that can lead to some safety failures or some insufficiencies to the AI system. So yes, we need to use in combination, but ISO 8800 is saying nothing about that.
But is this something that you probably foresee then?
Yep, for sure.
Regulation.
We will foresee it, and because of that, the idea is to work together also with cybersecurity team, because again, profiles of different knowledge are requested here, so we need to work together.
Yeah. Just a clarification: it's not pointing directly, let's say, on the. It's just only making reference on the risk, and the risk at the end points to the cybersecurity. Has a indirect relation, but yes, and as you've been saying, everything has to be together on this risk analysis treatment.
All right. So then I think, last question. We're coming back to the, I think, best practices for the safety analysis of data sets. Is it still commonly to use safety analysis methods?
In that case, I have mentioned two of the safety analysis methods that the ISO is recommending. Depending on which of the blocks are you feeding later. ISO 8800 mentions methods like HACCPs or process failure mode and effects analysis for training datasets. So again, these methods are expertise matter from the functional safety point of view. So in that sense, ISO 8800 is just pointing some examples that we need to further develop, but that's it. These are some proposals, but obviously we can use other methodologies and obviously other best practices. But ISO 8800 is just putting some examples, approaches, HACCPs and PFMEA like to use it and to analyze the safety part of the datasets.
Okay. So thank you so much. There were many questions. No new questions appeared anymore in the chat. So I think then we can say thank you to all the participants. Thank you to Narcis and Sergio for presenting the topic, complex one. For the participants, we will send out the recording and the slides so you can follow up with our two experts. Please don't hesitate to contact them. And I say thank you. So we're closing the session now.
Thank you, everyone.
Thank you. Bye.
Yeah.
Bye.
Bye.